In this lab, we will continue with data visualization using interactive plots with Plotly. Until now, we have looked at various kinds of basic plots available with Matplotlib and Seaborn. With Plotly, we could take our visualizations to the next level via advanced features that Plotly offers, namely options to dynamically choose the subcategory to plot the data, which could come in handy to selectively choose and compare multiple categories or subcategories plotted in the data. Customizations such as facets, marginal visualizations, geopolitical mapping, animation feature, which could be used to visualize the changes in the target data over a chosen continuous value such as GDP of a country versus time. Plotly provides an interactive plotting platform in Python. The interactiveness of the graphs are natively supported by Jupyter Notebook. Great examples of Plotly graphs can be found in this web address https://plotly.com/python/. So if I click on that, that takes me to a website. Let's plot a simple scatter plot but with the interactive capabilities of Plotly. First, we import plotly.express SPX. The cast data frame has looks like this. It has basic color, body type, CC rating, first New Zealand registration year, first New Zealand registration month, gross vehicle mass, import status, industry class, make, model, and so on. Marginal plots with an histogram. plt.figure bracket fig size equal square bracket 100, 100. So it's going to plot a figure with width equal 100 pixels and height equal 100 pixels. Let fig equal px.scatter of df cars, comma, x equal cc rating, y equal power rating. And if I type fig, that will plot the that will show the figure. So as we can see, as the CC rating increases, the power rating increases, but there are some power ratings sitting at 0 as well. DF cars, the cast data frame dot body type dot value counts open and close bracket gives me all the different kinds of body type and their counts. So we can see that saloon body type is the highest count of 258. Next is station wagon. Now we will continue with marginal plots with an histogram. On the figure above, we will add one more feature, that is color equal body type. So that will plot the on the x-axis is CC rating, on the y-axis is power rating, and the dots, they represent the body type. So we can see that these blue ones are a saloon body type. The green ones are station wagon body types, and they have high power rating. Station wagon has high power rating, and this pink one is convertible body type, and it has high power rating as well. Next, with the plot above, we will add one more feature, and that is marginal underscore y equal histogram. So let's have a look. So by adding that feature, we get the y-axis, which is the power rating represented by histogram. So we see that the body type, these bars represent the body type in the and that is for the histograms are created for the power rating. So for the body type, the pink one is utility. We see, and then we will add one more feature, that is marginal underscore x equal histogram. So the x-axis, the CC rating is represented by these bars. So CC rating, this long bar here represents CC rating 1800 to 1999, and the count is 72, and the body type is saloon. As we can see, the scatter plot above now can be interactive and show more information. Interactive, so interactive is basically showing more information. Like for example, if we place our cursor on any of these bars, it shows more information. The marginal underscore x and marginal underscore y options allow us to use the side plots to show more information on the data. Change marginal underscore x and marginal underscore y to show a violin and a box plot of the CC rating and power rating variables. So, so we change the marginal underscore y equal box, and we change marginal underscore x to violin. So the CC rating is shown by the violin plot. So we can see this light blue, the light blue one shows minimum 3907, lower fans 3907 for the service coach, and then median is 4927, upper fans is 11.045k, maximum is 11,045, and so body type equal utility, this for this orange one, and the CC rating is utility, sorry, the pink one, and the y-axis shows the marginal underscore y shows the box plot. So if I put my cursor on this blue one, that shows body type equals saloon and power rating equal 307. So if I move down to the thicker part of the box, then it shows the maximum is 307, upper fence is 290, quartile 3 is 122, median is 0, quartile 1 is 0, lower fence is 0, minimum is 0. For this purple one, this is for the body type motorcycle. Power rating is 999. So for the motorcycle, the upper fence is 114, quartile 3 is 110, median is 47, quartile 1 is 0, lower fence is 0, minimum is 0. Now with Plotly Express, the bubble graph can show much more. In the bubble plot, we add a third dimension of the data by linking it to the size of the marker. This could bring in additional insights from the data. So let's look at the gross vehicle mass value counts. So by doing data frame dot gross vehicle mass dot value underscore counts open and close bracket, we get that for the vehicle mass, gross vehicle mass equals 0, there is count of 238. And for the gross vehicle of mass of 1665, the count is 22, and so on. Let's let a fig equal px dot scatter of the cast data frame, comma x equals CC rating, comma y equal power rating. Fig dot show open and close bracket, and this shows that on the x-axis we have CC rating and on the y-axis we have power rating. Next we add one more feature. We add size equal gross vehicle mass. So this is going to grow these bubbles, these circles will show the size of the gross vehicle mass. So we can see for the higher gross vehicle mass is almost on the 0 line, where the CC rating and the power rating is almost 0. And when the CC rating is not 0 and power rating is not 0, then we see the rise in the bubbles, but the gross vehicle mass is less. Then we look at the value counts of the motive power. Cast data frame dot motive power dot value counts, value underscore counts open and close bracket, shows petrol is 740 count, diesel is 164, and motive power 0 has count 96. We let fig equal px dot scatter of cast data frame, comma x equals CC rating, comma y equal power rating, comma size equal gross vehicle mass, comma color equal motive power. Fig dot show open and close bracket, and we can see the color of the bubbles is represent the motive power, and there is 0. 0 motive power is where CC rating and the power rating is 0, and gross vehicle is 24,500. But for the for the power rating 0, CC rating not equal to 0, motive power is diesel, mostly diesel, and gross vehicle mass is nearly 14,224. So we see that where the CC rating is not 0, but the power rating is almost 0, is mostly represents the motive power diesel. And the blue ones are for the motive power petrol. And that is when CC rating and power rating is not 0, and the gross vehicle is about 2,490. Then we add one more feature. We do facet underscore call equal motive power. So what it does is that it creates the three facets according to the motive power. So there are three types of motive power: petrol, diesel, and zero. So it will create three graphs: petrol, diesel, and zero. And then for the petrol, we will see that when the CC rating is about has the CC rating goes mostly from about 1000 to just more than 5000, 5665, and the gross vehicle mass is about 2224. This one is 2665. And for the diesel, the CC rating is 0, and the power rating is 0, and mostly the CC rating is not 0, and mostly it represents bigger gross vehicle mass. But for smaller gross vehicle mass, we see their CC rating and the power rating is not 0. There is the gross vehicle mass is about 2000, about less than 3000, more than 2000, and it represents motive power diesel. For the motive power 0, CC rating and the power rating is 0, and the gross vehicle mass is about 24,500. Let's add one more feature. Say hover underscore name equal motive power. So that will add a name. So when we move the cursor around these bubbles, the title will represent the hover name, hover underscore name, and that is motive power. So this is diesel and this is 0. Let's add one more feature. Log underscore x equal false. So you can see that log underscore x equal false doesn't do much changes to the x-axis labeling. The tick marks labeling is 0, 5k, 10k, and let's see, after log underscore x equal false, it doesn't do any changes. But if I change it to true, then what does it do? So for the log underscore x equal true, we can see that we have the labeling has 100, 502, so 1000, 10,000. But yeah, so these are log scaling. These are log scales over here. So before we used to have 0, 5k, 10k, and now we have the log scale, and we can see that these graphs they are more of kind of shifted to the right. and for motive power equals 0, it's not even showing, because we cannot have 0 value on the log scale. So let's pull out the columns, the data rows which has nan, which has unknown value nan. So by doing the cast data frame bracket cast data frame dot is any open and close bracket dot any, inside the bracket we put x is equal 1 and it gives nothing. And if I want to choose all the data with motive power equal to 0, then we pass the command the cast data frame bracket the motive power equal 0, and then we want the motive power column, and that we can see that there are 96 rows with 0 entered has motive power. As we can see, the data has the motive power equals 0. That doesn't show anything. So let's remove it and replot. So let df cast 2 equal df cast, and we subset the motive power is in bracket, square bracket, petrol comma diesel. And we have this. And there are 904 rows. Then we will let equal fig equal px dot scatter of df cast 2, comma x equal cc rating, y equal power rating, size equal gross vehicle mass, color equal motive power, facet color equal motive power, hover underscore name equal motive power, log underscore x equal false. And we get this. So the motive power 0 is no more here because we have subsetted it. If I do log underscore x equal true, then let's see what happens. So we have the x scale in the log form. Try similar bubble plot on the household trouble. So we will continue in the next lab.